Good morning, good afternoon, everyone, and thank you for joining me today. I'm Raman Bhati, and I'm here to present our research on improving LLM generated unit tests through context engineering. Over the next 20 minutes, I'll show you how simple changes to your code comments can transform the AI generated test from barely usable to production ready. The key finding I want you to remember is adding strategic comments improve the test accuracy. Let me show you how. Um, Here is our roadmap for today. I will start with why this matters, the problem we are solving. Then I'll share insights from recent literature on LLM code generation. We'll cover our methodology and metrics, then deep dive into the findings with data and the code examples. I'll share practical prompt engineering tips you can use immediately. And finally, I'll wrap up with limitations, future works, and conclusion. Let's get started. Uh, First, why does it matter? Right, so according to GitHub's 2024 developers survey, over 70% of the developers are now using AI coding assistants. That's a dramatic shift in how we write code. Unit test generation is one of the most common use cases. We paste our function, ask for tests, and we hope for the best. But here is the problem: quality varies enormously. Sometimes you get perfect tests, other times the tests don't even run. Worse, sometimes the tests pass but don't actually test anything meaningful. They give us false confidence while the bugs slip through. How many of you have wasted time debugging the AI generated tests that looked correct but failed in mysterious ways? Our research provides a systematic approach to get consistently high quality tests. Let me show you how what the literature says about this problem. Let's look at what the recent research tells us. Performance on test generation benchmarks varies from 20% to 80%. That's a huge range. The temperature settings, which is also the randomness parameter, significantly impacts consistency. Then we have few shot prompting where you provide examples. That improves the result by 15 to 30%. But here is what caught our attention. There is no standardized evaluation framework yet. Different papers use different metrics, making it hard to compare approaches. Our work addresses this with a comprehensive four metric framework that I'll explain shortly. So, the table you see here talks about the literature identifies specific challenges, external API mocking, um, is the biggest issue. 85% of the functions that call the APIs get incorrect tests that try to call the real API. Then we have time dependent logic that creates flaky tests 75% of the time. The tests pass sometimes and fail other times. Then we have async await patterns. These are particularly problematic because 90% of the times I have seen that they get wrong mock types. Why do LLMs struggle? The root cause is fundamentals. LLMs cannot execute the code mentally. They see the source code, but they cannot understand its side effects, what external API is returning, or how the state flows. This insight led to our research question: can we bridge this gap with a better context? Um, the literature proposes several solutions. First one is fine tuning, which requires significant compute and is domain specific. The next one is RAG, which is retrieval augmented generation, which shows 20 to 30% of improvement, but again it requires some infrastructure. Then we have multi turn dialogue, which works, but it is time consuming. In this paper, we focused on prompt engineering, specifically what to include in the code comments and what kind of context should be given when asking LLMs to generate tests. Why? Because it requires zero additional infrastructure and it is immediately applicable and it can scale across different domains. The question is, can strategic commenting alone and providing the context alone transform the test quality? Let me explain how we measured the test quality. We used four complementary metrics. The first one is accuracy. Does the test correctly validate the function behavior? A test can pass, but it can be useless at the same time. Like asserting result is not none when you should check a specific values. The second one is success rate. What percentage of tests pass when you run them? This measures immediate usability. The third one is coverage. What percentage of code lines are executed? And then the fourth one is the mutation score, which is the most sophisticated. We mutate the code, change a plus to a minus, greater than to a greater than or equal to, and check if the test fails. High mutation score means that the tests are sensitive to code changes. Together, this gives us a complete picture of the test quality. Now, I'm going to present some of the results by adding comments to transform quality. The blue bars or the dark blue bars shows uh, metrics without the comments. The maroon bars show with comments. So as you can see, the accuracy jumps from 27% to suddenly 93%. The success rate goes from 70% to 100%. Um, the coverage is more than doubled from 44 to 96%. But look at the mutation score, the truest measure of the test quality. It goes from 13% to 87%. Without providing comments, the tests miss 87% of the code mutation. They are essentially decorative. They pass, but they catch nothing. With the comments, they catch 87% of the mutation. This isn't increment improvement, this is kind of a transformation. Now let's take a look at the improvement percentage by adding some comments. So you can see the accuracy improves by 82%, the coverage improves by 91, the mutation improves by 97%. The message is super clear. Comments just don't help a little, they fundamentally can transform the test quality. If you provide more context and more comments to the LLM that what this function is doing, it's more probable that the LLM is going to generate meaningful and comprehensive test suite for the given code. Now let's take a look at the context. By adding this context, um, starting from no context on this bottom side, bottom left, if you don't provide any context, look at the percentage. of the accuracy. We get 20 to 30% of the accuracy um, um, when you don't have any context. When you add some basic comments, the the range grows and it reaches to 30 to 35%. And then if you provide also full doc string, so we provided basic comments and full doc string both, and then suddenly the accuracy um, increased by in total 50 to 55%, right? And adding more context to that, meaning let's say we added some mock examples like how to test this code, or sorry, not how to test this code but how to use this code, and that increased the accuracy to 65%. And finally, when we also add the test templates like how to test this code, um, it reaches to 85 to 90%, which is a 20% point gain from just one additional um, change. So the test templates push you to 90 to 95%. The takeaways: mock examples provide the biggest single improvement. If you can only do one thing, show the LLM how to structure mocks, because that's where the LLMs get confused. If you are showing them how to mock, then they are more likely to produce the right tests. The next slide we talk about, which shows which code categories benefit the most. So we also did this research on different types of code um, in Python, right? So we added decorators and we checked the state machines, context managers, external APIs, async await, and so on. You see that async await, without adding the comment, we were not getting any test uh, uh, right correctly, right? And then after adding the comments, suddenly there is a huge increase. That's one of the most dramatic change we saw. Similarly, for external APIs, the improvement goes from 10% to 90% directly. For time dependent logic, um, the the change goes from 20% to almost 95 or 98%. Again, the pattern is clear. Categories which require specific testing patterns or libraries, they benefit the most from explicit guidance. If your code base is heavy on async or external integration, which usually is the case with production ready softwares, commenting for the test generation is essentially mandatory. In the next slide, we are going to talk about temperature, the randomness parameter within the LLMs. On the left, without comments, the accuracy peaks around the temperature zero point 0.3 to at 30%, right? So this is the most reliable area. The reliability reduces in this side while we go towards the x-axis, right? And then the um, creativity increases when we reach towards the 1. Now, um, on the left, without the comments, the accuracy peaks around um 30% and then drops. Higher temperature generates most tests but lower quality. On the right, with the comments, you see how it changes dramatically. The entire curve shifts up. Peak accuracy at 95% occurs at temperature zero point 0.5, meaning half reliable and half creative. Here is the insight: comments unlock higher temperatures. Even with the higher temperature, If you are providing the comments and then the context, it is going to be more reliable, even though it's more creative, right? The creative variation that were problematic without the context, they become productive now. So recommendation is temperature zero point 0.3 to zero point 0.5 with all the comments you can provide would be better for production grade test generation. Now, enough with the graphs and charts and all. I want to show the real code example in here. So this one is about the external API calls. On the left, you see that we did not provide any comments. And in the right side, we provided a doc string which basically shows the LLM what to do and how to test. So this kind of context is already given here. The LLM that generates a test and that calls the real API, no mocking at all, it fails without the network connectivity. On the right hand side, the same function with a comment explaining how to mock. Just one line. Mock request.get set mock return value JSON return value, right? That's all we are giving. That's all the LLM needs to generate the correct tests. Now, this is the example of the code with or without comments. Now, let's see how the LLM actually generated the test for without comments and with comments in the next slide. So, this one shows the actual generated test side by side. The incorrect test calls the fetch user data directly. It doesn't know that it is making a call to the external API. So asserts that result is not none, right? So this is where the result is not none, which is, I mean, it is going to pass the test, but it is completely useless. While the correct test on the other side uses patch, and this is something highly used mechanism to test Python code with the mock data, which creates a mock with the right structure and makes meaningful assertions. The difference, one comment explaining the mock structure, that's all. This is a pattern we see repeatedly. Now in the next slide, I am showing another code example, which is the time dependent function. This function checks if it's business hours 9 to 5, Monday to Friday. Now without the comments here, the LLM generates a test that just checks if the result is Boolean, right? All it is doing, if the result is Boolean, it is going to pass anytime. Completely meaningless, right? With the comments mentioning the freeze gun and then the specific test case, the LLM generates deterministic and more comprehensive tests. So let's look at the test in the next slide. Um, the flaky test on the left has no time control, right? All it is doing is just checking if this instance is boolean. The assertion is also useless. The correct test on the right uses freeze gun to freeze time. Each test covers a specific scenario. Monday 10 a.m. should be true, Monday 5 a.m. 5 p.m. should be false. It is comprehensive, it is deterministic, and it is meaningful. Just by adding two lines in the code in the previous slide, we were able to help the LLM understand the actual functionality of this test better. Now, quickly going to the third example, which is the async function. This is one of the most dramatic examples we saw with the async code. It fetches the paginated data. Without comments, LLM achieves 0% success rate on the async tests. Why? because they use regular mocks instead of async mock. They forget that the pytest.mark.asyncio decorator exists. Uh, the test returns a coroutine instead of executing it. Since it is returning a coroutine and they are expecting some value for 0, for 100% of the time the code is going the test is going to fail. With the comments mentioning the async mock in the comments, as you can see here, mock with async, not mock. You already tell the LLM that, hey, this is a different function, so treat it differently, create a test differently. The success jumps to 95%. Now let's look at the generated test cases. Again, here this is useless and it is going to fail. But in here, it creates the async mock. It calls the async client and waits for the fetch pages, and then asserts the result. So this is why the async code shows 95% of the improvement with the comments. Now this is the test generated chart. Another finding on the left, with comments, LLMs generate 3 to 5 times more tests. They understand what to test and create comprehensive suites. On the right, those extra tests also have higher success rates. Comments enable both quantity and the quality. Now there are some best practices I wanted to share. Um, Number one is mock structure, right? So you want to show the complete mock object shape. This is the single most impactful addition. Number two is the edge case list. Enumerate empty, none, and boundary conditions explicitly. That would help the LLM to understand where or which corner cases to check. The third one is library hints. You would want to mention freeze done, async mocks, and monkey patch, by name, so that the LM gets a hint that you know it's probably better to use those libraries. Then the next one is state warnings. If there is a global state or cleanup needed, say something like that in the comments. Finally, example test snippet. Even a one liner showing the pattern helps. Just by adding one or two lines can change the accuracy by up to 85 to 90%. In the next slide, um, I'm sharing the recommended comment template. So this one is the doc string, which you see here. It shows the args, what it's going to return, what exceptions it is going to what exceptions it is going to raise, the testing strategy, and finally the example test. This is the mutation score chart. Um, I think I didn't mention this one earlier. So let's revisit this one. Without the comments, the async tests catch zero mutations. Time dependent tests catch only 5%. But with the comments, all the categories reach 80, 70 to 80% of mutation detection. This is the true measure of the test effectiveness, and comments transform it completely. However, there are some limitations about this approach as well. Our study examined 20 different types of function categories. Broader validations would strengthen these findings. We tested Cloud and GPT-4. Other models may behave differently. We focused on Python. Um, we can try with other languages as well, but at this point, how the other languages will behave, it is still unclear. There is an overhead in writing detailed comments, and they must stay synchronized with the code. This is an evolving field. Um, the GitHub Copilot now has workspace level context. Cursor has its own rule system for project wide standards. Academics are exploring self refinement and mutation guided testing. We are working on automated comment generation using static analysis to suggest testing comments and building an ID plugin for real time suggestion. Looking forward, in the short term, uh, we would want to explore the automated comment insertion and ID integration. The medium term future work would be to have feedback loops using test execution results and coverage guided generation. And then the long term future work would be self improving tests that iterate based on the mutation results. So if the mutation result is get coming low, then we would want to have self improving test in order to increase the mutation result. So mutation result is going to be the north star in that case. This is the final summary of how the whole thing looked before versus after adding the comments. Um, as you can see, with comments, the success rate, coverage, mutation score, and accuracy all increased. And without the comments, it looked something like this. So, in all dimensions, having comments and context improved the um, improved the performance, accuracy, and all these measures. That's all. This is all I have for now. Thank you so much for watching this presentation.